Right, welcome to this paper. We're going to be looking at mock set 10, starting with a non-calc paper. What I'm going to start doing from now on, obviously I'll put the mark scheme in at the end, but I'll also be pausing for 1 or 2 seconds at the end of every question. So rather than you waiting for it, you can sort of scrub forward, check the answer. If you're good to go, move on to the next question, and so on. So let's make a start. Number one, right, let's write this as a product of prime factors. So remember, we're thinking with these sort of questions, it's saying what prime numbers do we multiply to get an answer for 72? Best way of doing it is just sort of break 72 into sort of factor pairs, right? So what any two numbers, avoid the number one here, but what two numbers times 72? Well, that's in the 9 times tables, and I know that's 9 times 8. So that's always a good start. The whole trick is you stop at any prime number, so neither of these are prime. We'll have to do 2 branches of each, right? 9 is 3 times 3. You can repeat yourself. And you'll notice that threes are both prime numbers. With 8, you've got a 2 and a 4. So the 2 is a prime number, you can stop there, but with a 4, you'll have to do another pair of 2s. Remember, in your answer, you should only see prime numbers. So the answer to this question, what we're saying here is you would get 72 if you did 2 times 2 times 2 times 3 times 3, which using indices would be, well, your 3 2's give you 2 cubed, times, well, 3 times 3 is 3 squared. So that's your final answer for number one. Now, number two. Remember, the trick to this, whenever you've got decimals and you're dividing them, you should remember that dividing is the same as writing in fractions. And the simple hack to get rid of decimals in any fraction is just either times it by 10, 100, 1,000, make both the numerator and denominator bigger. In this case, I'm going to multiply by 100 because I'll need 2 decimal places to move the decimal point at the top, thus making that 3,978. And if I divide the bottom by 100, I'll get 170. Okay, fair enough. So what do I need to do now? I want to simplify this fraction, right? Let's make things simpler. Let's think. So was this the easiest way to have done it? Probably not. I mean, okay, do you know what I'm going to do? I'm going to divide everything by 10, top and bottom. So I will get a decimal on the top, but on the bottom, I'll have a nice number 17. Okay, so the trick to dividing decimals is the numerator is okay to have decimals. It's the denominator you want as a whole number. So once you've got sort of 17 here, we can sort of now resort to bus stop method. And if you're not good with your 17 times tables like me, you can sort of work out the first few numbers like this, by adding 51s, by adding 17s even in my head. I mean, the next one will be 68 and so on. Okay. So let's do this, right? How many 17s? Well, none go into 3 because that's too small. Carry the 3 over. 17 goes into 39 twice because 34 fits. That would give me an extra 5 as a remainder, so that will be carried on to the next one, 57, which, looking at my sort of table there, we'd have 3 lots of 17, which would be 51. Again, that's 6 short. Now, because this is where the decimal point goes, I'm going to carry it up here. And 17 goes into 68 exactly 4 times. So the answer to this question would be simply 23.4. I'll leave it there. Again, I'm pausing at every question just to give people a chance to fast forward, just so they catch it. I think that's enough time now. We can move on to number 3. Okay, Sarah, what you got for us? 280 plants, apparently. And they're one of 3 plants. And we know 2/7 are trees, 40% are roses. So how many are... Okay. Okay, so there's 4 types of plant. I totally misread it. But yeah, let's get cracking, right? First of all, 2/7 are trees. So T will represent the number of trees. Fraction of. So look, anytime you see the word of, replace it with the time sign. And to deal with these sort of questions, you divide 280 by the denominator times by the numerator. So we'll do just that. So 280 divided by 7 will be 40. And then we times by the numerator, which will be 80. There are 80 trees. Nice. 40%. So again, we'll do roses next. So it'll be 40% times 280. So that would be what, 40, 280. And again, same idea, really. I mean, I don't know, some people might prefer to just say, well, 10% would be 28. So we'll just times that by 4. Various ways you could have done it, right? So what's 28 times 4? Let's work it out. 4 8s are 32, 72, right? So there are 72 roses. Did I get that right? I've got a bad feeling about this. Of course, I've got a bad feeling because that's not correct. Let's do that once more. Carry the 3. 3 it's 112, isn't it? I knew something looked off. 112 roses. All right, so we need to add these up, don't we? So let's eliminate the number of trees and roses from 280. So we'll do 280 take away. Let's add these two up first. So to sort of keep track, I'll add these two together. 192. Take that away. So 280 take away 192. You've got 88. Okay, so you've got 88, which is the number of daffodils to tulips. So we now know 88 daffodils and tulips. So the last part is to share 88 in the ratio. Daffodils to tulips is 5 to 6 in that order. So we're sharing 88 in the ratio 5 to 6. Adding those parts together, 5 plus 6 is 11. Do 88 divided by 11, which is 8. In other words, multiply each of these by 8, right? Each part of your ratio represents 8 plants in total. So let's wrap things up by multiplying both the daffodils and tulips by 8, thus making there 40 daffodils and 48 tulips. Which number did it want? Tulips, right? So yeah, just highlight the right number at the end. Tulips was the second letter. There are exactly 48 tulips. And we are good to go. So again, I'll leave that up there just for people who are scrubbing forward. Very cool. Number 4, scatter graph. Okay, so always read these questions carefully. But yeah, it wants you to plot this point. So make it clear that you have read this. All it wants you to do is just to put an cross, just like the other points, at 160 and 15. So that would go exactly here. Be accurate, please, people. But yeah, if the examiner doesn't see that, don't be surprised to not get the mark. There we go, easy mark. That's probably the easiest mark in the whole paper. Okay, the relationship between the heights. So be really, really careful here. Yes, there is positive correlation. But when it says the word, so some questions say what's correlation. If they say relationship, I would say both positive correlation, but then follow it up with saying it means give this context. Okay, so we would say positive correlation, the taller the person, the bigger the hand span. So when it says the relationship, it basically wants you to give it context. Give it meaning. Don't just say positive correlation. describe what it actually is talking about. Okay, so next up we've got estimate Chris's span. I'm assuming Chris is a boy in this question. Uh, all right. So what we want to do here, and again, mine's going to be a bit sloppy because I don't have a. It's hard to draw straight lines on an iPad, but I would get a ruler and I'd draw a line of best fit before I approach this question. So imagine you'd use a ruler here, and it doesn't have to go through any points, but it should have sort of roughly half on one side or the other. I think that's fine. You might argue that actually I could have probably done this better and draw it slightly lower. Again, there's no exact science, or at least not in at GCSE anyway. But yeah, you just want a line. Don't worry if it doesn't cross any point, as long as it's roughly sort of in the middle. So that would be suitable, and that'll get you 1 mark. The second mark we get from actually using the line of best fit properly. So we want to estimate somebody with 155, which would be here. And again, you would need a ruler for this part. So you draw a straight line up to the bit where it hits your line of best fit, and then you do a line vertically down. And I know mine's not perfect, but I think that's roughly speaking around. I mean, the scaling's not very good, is it? But like 15.8, I think, would be a good estimate. So 15.8 centimeters hand span. Now, the mark scheme, let me read it out for you. Part C. What question number are we now? This is what, number 4. Allows an answer in the range of 16 to 17. So, you might argue that my line of best fit is probably not very good, which is does surprise me a little bit. I would have thought I would have been just within range here, but I missed out. So, I think that's a bit mean, really, isn't it? So it means a better answer would have been to draw the line maybe slightly lower than I have done. Again, this is a mock paper, so not a real GCSE, but they're saying 16 to 17. So I would have lost, I would have been 0.2 out. I think that's a bit harsh. This was not an official GCSE, but again, that's that. There we go. So the mark scheme says that I would have lost a mark here because the mark scheme does say 1 mark for line of best fit, which I got, but I'm just out of range there. So just goes to show you the importance of an accurate line of best fit. All right, number 5. So we got a table of probabilities here. In the bag, they're only red, blue, green, and white, no other colours. Find X. Right, well, we know all of these add up to 1. The sum of mutually exclusive events are equal to 1. In this case, all of these 4, because nothing else can happen. So we'll add the red and blue to begin with. If you add these two, you get 0.55. And we know that because all 4 add up to 1, if I do 1 take away 0.55, which is 0.45, that will be equal to getting either green or white. So I need to share out, well, there's 2x and 1x, that's a total of 3x equals 0.45. So one value of x would be that divided by 3, which 0.45 divided by 3 is 0.15. So x in this case, is 0.15. That's probability of getting a white is 0.15. Now, we are told there are 12 red counters in the bag. Even if you don't get part A right, you should still be able to do this question, right? Because you know that 0.2 is 2/10 or 1/5. So basically what it's saying is 1/5 of the bag is 12 red. So, I mean, just times that by 5, right? If you want to know what the whole bag is, one bag, well, 12 times 5 is what, 60, isn't it? So various ways you could have got that. So 60 being the number of total counters. Again, that's the right answer. Mark scheme agrees with both of those. All good. Let's scroll forward. Number 6, Sarah and Tim set up their phones. Okay. Now, any sort of question where they're like, there's two people, um, one is every 10 minutes, one is every 15 minutes. To me, this is screaming lowest common multiple of 10. And in this case, we don't know what y is, but we know the answer to that. The lowest common multiple is, well, how many minutes are there between 7:25 and 8:45? So minutes, let's work that out first. 7:25 and 8:45. Well, from here's what I'm thinking about. From 7:25 to 8, that's a total of what, 35 minutes? Because that's how many you need to start the new hour. And obviously 45 minutes from 8 to 8:45, right? So in total, there's 80 minutes, right? So coming back to the original question, the lowest common multiple of 10 and y is 80, this number. So my initial instinct said to say 8, but I know I'd be wrong because I know that the lowest common multiple of 10 and 8 would be 40. So I bet a lot of wrong people here would have said 8. If you said 8, you're wrong because 8 has a lowest common multiple of 10 and 8. Smallest number in the 8 and 10 times tables is, you guessed it, 40. So what's it going to be? It's going to be 16. Now, I want to show you a different way we could have got this answer. Lowest common multiple questions. Usually Venn diagrams help. You could go as far as potentially, remember, LCM is when you multiply all numbers. Now, we know 10 and we know y. So with this, the smallest value of 10 and what? So we know that all three areas multiply to give 80, right? The y bit, the bit they overlap, and the 10. So we want this to be the smallest possible value of y. So how would we get that? So I would want to get the smallest value of y, and I'm just thinking like, how can I apply this to bigger numbers? Because you may not always get a nice pair like this. Yes, the answer is 16. If you don't want to hear this, fast forward. But I'm just going to sort of ponder here. But if I wanted the lowest common multiple of this whole Venn diagram, usually we'd multiply all three areas, right? Now, if I know that this circle is 10, in order to get the smallest area, I would say, well, let's pull the number 10 in the middle. Let's overlap these perfectly. So what effect would that have? Um, so 10 times... So the lowest common multiple of 10 numbers 80. How can I get y to be a small... No, hang on, I've done this wrong, haven't I? Let me rub out the 10 real quickly. I want not the whole LCM to be as small as possible, because LCMs could be 80 no matter what. I want y to be as small as possible. So what I mean by that is let's put the 5 and the 2 on the outside. So what would have to go in the middle would have to be 10 times... Would it have to be 8? But of course, if it's an 8, that means they've got a 2 in common, which would make this not work. So the reason I can't do this is because right now they share a common factor, don't they? So unfortunately, that's not going to work. Uh, it would have to be 2 in the middle. And of course, I need it to be 80, so this is going to have to be an 8. So LCM, you times all three together, and y would have to be 8 times 2. I know that this doesn't use prime numbers. You don't have to use prime numbers, although most questions it does help. This one, we don't really need to use. You make use of that. Anyway, I've spoken for long enough. Um, very cool. Let's go with number 7. Okay, what inequality is this? Well, x are numbers bigger than -2, but also because it's shaded in, it's also equal to -2, so greater than or equal to -2. Part B, solve. Solve the same way you would do any equation. The only trick here is don't get rid of that arrow sign. Just keep that throughout. So we'll move all the n's by adding n to both sides. So that would cancel out these two. It would leave you with 53 here. Is 14 plus 6n. Then we're going to subtract numbers this time, right? So take away 14 now from both sides. So 6n would be greater than 39. I'm going to divide both sides by and I know what a lot of you are thinking. Divide by 6. I'm going to do something a little bit different to begin with. I'm going to divide by 3 first because I've noticed that both of these numbers are in the 3 times tables. And the reason I've done this as opposed to just dividing by 6 in one go is, well, all I've got to do now is half 13. It's not going to be a whole number. So n is greater than 13 halves. You could write that as n is greater than 6.5. So either one is fine. They would accept an improper fraction or a decimal. All good. Okay, there we go. Number 8. Ali, Barry, and Dev. See, this is funny because usually they like to do A, B, C. Names start with A, B, and C, but this time they've gone a bit left field and they've gone A, B, D. Anyway, we move. So Ali, Barry, Dev, sharing them out. 1, 2, 3. Dev gives some. Okay, so there's a bit of sharing, a bit of dealing going on here, and there's a lot going on. Okay. Okay. All right, so this is going backwards, isn't it? So they both start, just to sort of try and make sense of this, people. I'm thinking in these terms, right? So they start where Ali, Barry, and Dev, 1, 2, 3, we don't quite know what the money is, but we know at some point, sort of the end, some money is exchanged, isn't it? So Dev loses his part of his money or his share, and he gives it to Ali. Barry stays the same though, which is interesting. So that's going to be something I'll come back to later. But we've got 3, 4, and 2. So the new ratio, or the N ratio, if you will, has Dev on £120. So if we compare the sort of the two parts to 20, clearly this has been multiplied by 60. So we can use this information in an interesting way. We could just times all of these by 60. Ali will end with £180, and Barry will end as he started with 240. Okay, cool. Oh, actually, although I made no mistakes, I did clock that Dev has actually given money to both the boys, hasn't he? So actually, it's not going to be as easy as I anticipated. But anyway, we have done the first part, right? So Yeah, so here's what I'm thinking. The total amount of Ali, Barry, and Dev is 180, 240, and 120, right? This is enough information to work out totals here. So the total amount will be 540. And this is important because this is how much they start and end with. Yeah. And we need to go back to the beginning now. We can use this number here to know to begin with how much did they start with. Well, in my ratio there, the 1 to 2 to 3, we divide by 6. 540 goes in 6 90 times. So at the start, Ali had £90. Barry had £180 and Dev had £270. So let's wrap this up. How much did Dev give away? Well, to compare that, work out the total amount of money Dev gave to Ali and to Barry. So altogether, well, let's just work out how much did his money go down by, right? So he started with 270, he ended with 120. What's the difference? Because that will obviously be the amount of money he gave away. So £150 is the money he gave to both those boys, obviously in different amounts. So £150 is the money he gave away. I mean, you can eyeball the amount. Ali got £90 more. Barry got £60 more. I mean, you could have done it that way. That's probably just as easy, to be fair. But 150 is the answer. Well done if you got that. Number 9. We got 3 squares, A, B, and C. Interesting. Now, with these questions, you can do algebra, or you can deliberately choose numbers, which I like. So let's say, or let's assume A is 100 centimeters squared. It doesn't matter. I mean, you can pick 100, 1,000, a million. It doesn't matter. Or you can use the letter X, because this will be true for any of them. On the mark scheme, it says any number works. So look, if the area of A, I'll just choose 100 because of the percentage. Well, if B is 10% greater, B will be 110, right? Just 10% more. And C is 15% greater than B. So the area of C, 10% of B. Oh, I don't want to. So 10% of B would be 11. So 15%, well, half of that would be 5.5. I'm not actually doing percent. I'm doing centimeter squared, aren't I? So add those together. 15% means it will be 16.5 more than B, right? So we can argue C is 126.5. Yeah. So we've increased A by 10%. We've increased B by 15%, and we've got the areas of A, B, and C respectively. So the question says, what percentage of the area of C? Wait, let me read this again because I want to get this right. By what percentage is the area of square C greater than the area of A? Well, percentage change is going to be, this is a percentage change question. How much is it bigger by? Percentage change, and remember this formula, it's the difference over the original times 100. So the difference, first of all, is by how much has it gone up by? Well, 126, take away 100. This is easy, it's just 26.5. Now the original, because A was the original shape, this is where it all started. We'll divide by 100. And then to turn into percentage, we times it by 100. Well, lucky us, the hundreds cancel out. How lucky was I? This is why I always like starting with the number 100. So the answer is 26.5%. So if you said 26.5%, there are various ways you could have done it. I'm not saying you had to do it my way, but yeah, 26.5 is the final answer. Well done if you got that. Moving on, number 10. All similar triangles. Okay, so what do we know? We know triangle DEF, that's the bigger one, is 37.5 centimeters squared. Interesting. Okay, so you should remember, we'll call this, I'm going to avoid H because that's the little triangle, so let me call it X. Okay, any letter will do. But you know the area of a triangle is, area is a half of base times height. So 37.5, the area of this big triangle, equals 1/2 of the base, which is 5, times height, which we don't know. Well, in my case, I'm calling my H for the bigger triangle as the letter X. So let's solve this. Let's solve what X is. I'll start by multiplying both sides by 2, because that would cancel out these two fractions on my right. And on the left, 2 lots of 37.5 is 65. So 5x is 65, divide by 5, which gives you, how many 5s in 65? 13. Okay, the height of the big triangle is 13 centimeters. I can add that up here. I'll leave X there just for people who don't know, but look, cool. Next up, I want to compare the scale factor. So to go from the small to big shape, the scale factor, SF, is usually the bigger side divided by the smaller side, right? You can write 1.25, but I won't. I'll just write it as a fraction. It's without a calculator, fraction's going to be a lot easier to work with. So I know my last bit of working now, I'm thinking about the relationship of both heights here, but usually to go from here to here, you would say, right, we'll take H, and what I'll do is I'll multiply it by the scale factor. What I'd do is I'd multiply it by 5/4, and as a result, I would get my new length, which is 13 centimeters. Well, I'd get a bigger length, yeah? So basically, our job now is to solve this. What is H? Well, I can multiply, there's two ways, we'll times both sides by 4 to begin with. So you will get 5H, fractions cancel out here, equals 13 times 4, 52. So H is 52 divided by 5, which is very strange because that doesn't make sense. That's going to be 10 point something. Oh no, that does make sense because it's less than 13. All right, forget me. I thought, yeah, so if I'm thinking sort of mixed number wise, it's 10 and 2/5. You can probably write this as 10.4. But yeah, that should be the answer. Let me check the mark scheme. I got a bit worried there because I thought the length would be smaller than, hang on a minute, number 10, it's saying I'm wrong. Shocking scenes. Let me find out where I went wrong. My bad, people. We're gonna have to have a VAR check on this one. Where did I go wrong? Where did I go wrong? Okay. Times by 2. Ah, nightmare. All right, VAR check. Believe this. Cannot believe it. Sorry, people. Hats off. The scale factor bit's still right. I messed up here. Oh, I can't believe this. Shocking scenes. 2 lots of 37.5 isn't 65, it's 75. What an absolute silly billy that I was there. Right, so that makes the question a little bit easier, thankfully, for us. So X would actually have been 15 centimeters. I would have probably lost 1, maybe 2 marks with that gaff. Right, so X is 15. Again, everything I said earlier was right. It was just that little mistake. So remember height, which according to my diagram I did in purple, is multiplied by my scale factor 5/4 and not 65, but equal to 15. So we'll solve this. I'll do this last bit in green. Times both sides by 4. So you got 5H equals, well, 15 times 4 is 60. Okay, and then divide by 5, you get H is 12. Can't believe I did that. Yeah, messed up. Happens. So yeah, 12 is the answer. If you're screaming at the screen because you noticed me make that mistake earlier, don't worry, I hear you through the screen. Okay, it's 12 and we move on. Apologies for that. Number 11. But, it just gives you a bit of honesty there. Teachers aren't perfect, we make mistakes, but the working lets us off the hook. I might not get 100% people, but I'm definitely getting a grade 8, most likely a grade 9 because of my working. Okay. All right. What do we got now? 11. We got we got 3 liquids. We got 2 liquids get mixed to make a new one. A, B, C, right? So first things first, do you remember the formula for density? D equals M over V. The way I always remember is, and this is a bit random here, but in America they have, where you get your driving license, it's called the DMV. Don't ask me why I remember that, but it helps me remember this formula. DMV. Whatever works, right? Find your own way. Density is mass over volume. Another way you can always there's a bit of a cheat code here, but look, if you look at the units of density, they always have kilograms per meters cubed. Think about that. Kilogram is a unit of mass. Meters cubed is a unit of volume. So you can sort of cheat. If you forget the formula, look at how they've written density. It's always mass over volume, isn't it, right? Yes, it's written side by side, but usually, kg / m cubed means kg divided by m cubed, right? Or mass over volume. So you can sort of cheat code. Same thing happens with speed and sort of pressure. If you forget those other 2 formulas, that's a little cheat code for you. I give that free of charge. Just give me a like and a follow. That's what I ask. But anyway, back to the question. So any question where you've got multiple densities or multiple speeds, the first thing you'll do is you'll give yourself a nice table, right? You'll see what I mean in a minute. But look, we've got, in my table, I'm going to break into speed, no, not speed, what am I talking about? Density, mass, and volume. Density, mass, volume. Again, I'd usually use a ruler. Probably I'd do it slightly smaller in a real exam because, it's on an iPad, it's on a video. You want it in that 4K vision, people. So your table looks something like this. And obviously we've got our 3 liquids, A, B, and C. Right, just fill out the table, right? What does the question tell us? Let's just pick numbers from the question itself, right? So liquid A is a density of blah. So let's write that there, 160. Let me do this a bit more clearly because my 160 looks a bit rubbish. 160. Liquid A has a volume of 4 meters cubed. Okie dokie. Same with B. B has a density of 600. It's a bit more dense, not gonna lie. And it has a mass, right? So we got 3600 kg. Okay. And it wants the density of C. So the whole question, this is what we are after, right? This thing here. All right. So one thing you need to know is never, ever, ever, just don't ever add densities together. This is not going to be as simple as 180 plus 600. If you do that, you're in the wrong, right? You can only add masses and you can only add volumes, but you cannot add densities. And it's just struck me that I highlighted the wrong thing in green. This is what we want at the end, right? So how are we going to achieve that? Well, let's focus just on liquid A, right? Liquid A, if I use the formula density is mass over volume, well, I know the density is 160. Let me substitute D with 160. Let me substitute V with 4. And that's enough information to work out the mass, right? We multiply the 4 across. 160 times 4 is 640, right? So you will get a mark for identifying or finding that the mass of liquid A is 640 kilos, right? Happy days. And likewise, for liquid B, we know using the same formula, we know density 600, we know mass, but we don't know the volume, right? So let us work that out. So here we will multiply across the V, but we'll divide by the 600. So it'll be 3,600 divided by 600. 36 divided by 6. What? 6. Okay, we are cooking. So, I can't believe I said that. Sorry, guys. I know it's cringe. The older person in me had to come out there. Yeah, don't put too much slander in the comment section. But how's this going to help me work out a liquid? Let's see. Right, things we can add. We can add masses. So what I'll do is I'm going to write total mass, i.e. mass of C, will be 3,600 plus 640. So that will be 4,240. And the total volume will be 10. I'm not going to do the working there. So density, in green, mass over volume, 4240, divided by 10, cancel the zeros off. It's just 424, isn't it? I'm pretty confident this is right. Let me double check. 424 kilograms per meters cube. Right, VAR check complete. We are good. So well done. Yeah, always draw a table with, and guys, this if you're doing a speed, like if you're doing average speed, say if you've got like two different speeds, say like you took a train and you took a plane and you want to work out average speed, you do need a table similar to this, right? Obviously the heading would change from DMV to SDT, but you get the idea, yeah? Cool. All right, 12, recurring decimals. We love a good recurring decimal. For the people who have forgotten, x X basically is the fraction, right? We don't know what it is yet. Call it X, call it whatever you like. Pick your random letter. But because the dot's only over the 2 and not the 3, it's actually only 3. You only see the number 3 once. It's the 2 that repeats itself, dot, dot, dot. So we will multiply this by 10 because the 0.3, the 3 tenths become 3 ones. This one becomes 2 tenths. That becomes your hundredths and so on, right? So when we subtract these, 10x take away 1x is 9 lots of x. And if I use column subtraction here, well, all of these digits are all 2, so they cancel. If you're taking them away, they cancel out. All you got to do is do 3.2 take away 0.3, borrow 1 from the 3, 12 take away 3 is 9, 2.9, right? Cool. So 9x is 2.9, x is 2.9 over 9, times your top and bottom by 10, x is 29 over 90. Does this cancel out? Can we simplify this? No. 29 is a prime number, so that's as small as we can go. So 29 over 90, if you got that, well done. We love to see it. Right. Here is triangle ABC ABCA. Let's work this out. I'm going to take a phone call. I'll be back in. Well, right. Okay, right. So question number 13, triangle ABC. Don't mind the scribble there. And we know it's got an exact area of 18. And you need to work out the exact length of BC, this side. Right here, let's call it X because we don't know what it is. All right, so area of a triangle, it's not a right-angled triangle, so we're going to use the formula, which you should know. A is half of AB sine C. So for the purposes of this question, the easy one to start with is C. It's the angle here. A and B are the sort of two lengths either side of that angle, so we'll call that A and that B. Doesn't really matter which way around we name them. But by substitution, we can say that the area A equals 1/2 A, which is 12, B, we don't know yet, X, that's the whole point of the question, multiplied by sine 45. Now, we also know what the answer to this question is. We know it's 18. So actually, we can say 18 equals all of this. And actually, to tidy things up, I'll just say that the half times the 12 give me 6. You can write 6x. Again, if you've got a number times next to a letter, it means times anyway. And then obviously the sine 45 comes down as well. Times sine 45. Okie dokie. So, we're well into this question now. But you might be thinking, well, what on earth is sine 45? Now, if you're really good with sine, with trig values without calculator, because of non-calc paper, remember? If you remember the table, chuck it in. If you know what sine 45 is, well done you. If you don't know what sine 45 is, and you like to know, and you hate memorizing tables, I got you. Imagine this, right? I want you to picture a triangle, a right angle triangle, where it's isosceles, right? And you know the isosceles triangle, if one of the angles is 90, the other two have to be 45, right? Now, I'm going to purposely choose side lengths 1 and 1, right? Isosceles triangle, so they both have to be 1. You can use Pythagoras to get this sort of hypotenuse side here. So 1 squared plus 1 squared is 2, and obviously you square root that to get root 2. Why am I doing all of this, you ask? Because I now know that sine 45 is, again, this we can use SOHCAHTOA. Sine 45 is opposite 1 over root 2. So actually, look, I've just found what sine 45 is. Now, I know what a lot of people are going to be saying, sir, that's a bit naughty because you did not rationalize your denominator. Don't worry, I got you. The trick here is we times the top and bottom by root 2. So the probably what most people memorize the table will know the answer to this as root 2 over 2. So yes, sine 45 is root 2 over 2. So let's go ahead and substitute that in. So sine 45 root 2 over 2 times your 6x equals 18. Okay, so a few things we can do here. Let's move the two. No, I'm just thinking what's the easiest way to deal with this question. Do you know what? Let's divide both sides of this equation by 6, because I notice 18 is in the times tables, and I also know that 6 is in the times table. So we've got 3 equals x multiplied by root 2 over 2. And I'll multiply the 2 across. So 6 is equal to x root 2. And then I'm going to divide by root 2. So x is 6 over root 2, which we want to rationalize this denominator, don't we? So we'll times the top and bottom by root 2. So this would give me 6 lots of root 2 over 2. I've now rationalized the denominator. And if you focus clearly, we can simplify the 6 divided by 2, which is simply 3. So the answer to the height, that missing length, was 3 root 2 centimeters. Very tricky, that one. Well done if you got that. So you do get 1 mark for identifying sine 45 as 1 over root 2. You don't necessarily actually even have to rationalize the denominator here to qualify for that first mark. You get another mark for this. You don't even have to know what sine 45 is at this point. You just have to set the equation up with just sine 45. So that's 2 marks. 3 marks for having some sort of working that leads to x or BC. So the third mark would probably come from here. And then obviously your 4th mark for sort of dealing with the unrationalized denominator there. So that's a really tough one. Well done if you got that. Okay, number 14, prove. All right, prove that any odd number greater than 1 is always one more than a multiple of 8. There's a lot of words going on here. So if English is not your first language, this will be double tough. So let's think about it. The square of any odd number, right? So algebraically, actually, you know what? For people who like to scroll, let me just say what I hate seeing as an examiner. please don't just say 3 squared is 9, which is obviously one more, 1 plus 8. Please don't do this. Don't do this. Because there is no such thing as proof with example. Yes, you've shown it for one value, but when we prove it for all values of n, we need to generalize using algebra. So if you did that, even if you said like 5 squared, 25, and that's 24 plus 1. Yes, I get it, because like 3 times 8 plus 1. Yeah, it's one more than multiple of 8. I'm not saying you're wrong. You are demonstrating it in action, but you are not proving it's true for all values of x. You've only proved it for one or maybe two values of x. For all of them, you have to use algebra. So let me preface this by saying must use algebra. So if we're going to use algebra, let's think about how can we represent all odd numbers? Well, the generalized way of writing odd numbers, well, even numbers are 2n, right? Because even numbers are numbers in the 2 times tables. So odd numbers are 2n plus 1. Yeah? So you will get 1 mark for just saying and generalizing that all odd numbers can be generalized to be 2 times a number plus 1, right? This is like the family of all odd numbers, sorry. So this question says the square of this. So the square of any odd number. What happens? Well, square of any odd number. Okay. So let's square it. So we're going to square 2n plus 1. And if we do that, it will be like writing double brackets. And here is what we get. We're going to expand the double bracket. So this times this is 4n squared. This is 2n. This is 2n. This is 1. So we end up with 4n squared plus 4n plus 1. Now, interestingly, and this is what made me hesitate slightly earlier, we need to prove it's a multiple of 8. Usually, we'd be able to factorize 8 out of the question, leaving the plus 1 at the end. But there's no 8. And initially, this would be cause for concern. Okay, but here's what you need to do. We are going to factorize just the first pair. Remember, we want one more means let's leave that plus 1 at the end alone. Right? We want our proof to say one more. But I'm going to factorize this, right? Now, common factors are 4. They also have an n as well common to both. So if I factorize the bracket, I'll get 4n bracket n plus 1. Now, check this out. This is a thing of beauty because, and this is where probably words need to come into play here. You would say either n or n plus 1 is even. So when also multiplied by 4, the whole thing, actually I want to use technical words, the whole expression will be a multiple of 8. So what do I mean by this? I mean, well, look, remember, n can be any number. But if, like, let's say n was, I don't know, 5, for example, this would have to be 6. Yeah? And if this was, 12, this would be 13. So you've got this situation where either the n at the beginning, the one outside the bracket, is the odd one, or the n plus 1 is the odd one, but the other one's going to be even, right? And the important thing is either one of those two has to be even. And because an even number is in the 2 times tables, when you times it by 8, when you times that even number by 4, it automatically becomes a number in the 8 times table, right? If you've got to take any even number, times it by 4, has to be divisible by 8, right? Because even numbers are divisible by 2, times 4 has to be also divisible by 8. Cool. So there we have it. So there. This we've just shown. So this must be a multiple of 8, hence any odd number squared is always one more than a multiple of 8. There we go. That was a hard proof because usually these sort of proofs, the multiple part, the 8, you can easily factorize for a lot of these questions. That one has an extra dimension of difficulty because you've got to spot that if you got n and n plus 1, if one's odd, the other one has to be even and vice versa. Okay, so this one's a combination of translations here. We've got A gets translated to B, B gets translated to C. Basically add these together, right? Let's add these. So if you're combining more than one translation, you add the vectors together. So -2 plus -6, you can add the horizontal components first, which would be -8. And you can do the same with the denominator, the horizontal component, which will give you -2. So A to C, you would say to map A onto C, you would translate shape A by vector -8, -2. Okay. Jatinda. Or Jatinder, who knows? I've not really seen this name before. If I enlarge shape A by a scale factor -4, the shape will get smaller because it's... Okay, no. No. In order for enlargement to be smaller, it would have a scale factor between -1 and 1. Yeah, so basically the idea is it has to be a number less than 1 but bigger than -1. So that would be a suitable reason. You could have also said no, or I'll say, you could say what the right conditions would have to be for it to be a smaller shape, or you could also say no, because scale factor of -4 would actually 4 times larger just on the opposite side of the center. So, the first reasoning is the conditions for him to be right, which clearly haven't been met in this question, because -4 is not between -1 and 1. Or you could say, well, he's wrong because if we follow through this, it would actually be a bigger triangle. So both of those are fine. But yeah, you have to say he's wrong or no or something to that effect. You can't just say it's bigger. You got to say yes or no, basically. Number 16, an estimate of the gradient at 4. So get your 4, get your ruler out, and draw a straight line as best as you can that touches that curve once at the curve at t equals 4, right? Doesn't matter how big that green line is. I'm on an iPad. I know it's not perfect, but straight enough, I think, for you to understand what I'm trying to do. Okay, so we need an estimate. So remember, gradient is rise over run. Pick any 2 points on your gradient. I'm going to pick preferably ones that are easier to read. So look, there and there, these are nice sort of where the bold lines meet. So I'm going to just pick those two. Draw yourself a triangle. Gradient is rise over run. So don't always assume the scalings are the same. My rise is 4. Over run is going to be 1, 2, 3, 3. So it'll be 4/3. So I'm getting 4/3, which would be 1.3 recurring. The mark scheme says well, you get 1 mark for simply drawing the tangent, 1 mark for finding a method to get the gradient. So my rise over run here would be suitable. The bit that I'm scratching my head around, the mark scheme says answer between 1.2 to 1.3. Again, this is a mock paper, so the accuracy mark comes from 1.2 to 1.3. I think when I have seen this in past papers, I've never seen the window for accuracy to be so small on a tangent question. Because technically speaking, I'm out by 0.03 hundredths. I think that's a bit mean. I'm just saying what's on the mark scheme. This is a mock paper, so it did not officially happen. I think 1.3 is a bit too harsh. Realistically, they'd probably accept sort of 1.1 to 1.5. But I'm going to write it anyway. Would I get 2 marks? Who knows? That was harsh. Mark scheme says that. I am going to sort of stick to my guns and say 1.3 or 4/3 would be fine here. What does a gradient represent, right? Well, think about what you've just found. You found the change in distance over the change in time. Change in distance over time. Distance over time. Where is that familiar? No, hang on a minute. Yeah, it's this change in distance over the changing time. So it's speed, isn't it? Or velocity. Velocity. You can use either word here in this context. At t equals 4 seconds. Okay? Very cool. Number 17, right? We're nearing sort of the later stages of this paper now. Solve this equation. A few ways to do it. So I'm going to add the fractions together. I will multiply the first one, top and bottom, by x plus 1. Why do this, you ask? Yeah, why indeed? Because I'm actually multiplying it by the wrong amount. I'm going to multiply the first one by 3x minus 2. Apologies, people. And the reason I'm going to do this is I want to bring both fractions under one common denominator. So actually, I'm going to multiply the right one by x plus 1 and the left one by 3x minus 2. Because that would give me in the first one, 3 bracket 3x minus 2 over... And I'm not going to use brackets... I'm not going to expand the brackets just yet. Plus, and then again, the one on the right-hand side, I'm multiplying by x plus 1, aren't I? So, look, the bottom of both fractions now, again, all of this is equal to 1, but you get what I mean. We can bring this all over one common denominator now, that being x plus 1, 3x minus 2. And let me expand that bracket That'll be 9x minus 6. And this bracket on the right will be 4 plus 4x plus 4. And again, remember, this is all equal to 1. So let's tidy up the numerator on the left-hand side. We've got 9x plus 4x, that's 13x. The minus 6 add 4 gives me take away 2. All over x plus 1 and 3x minus 2 equals 1. Now, at this stage, I want to get rid of the fractions altogether. So I'm going to multiply both sides by the double bracket, by not just x plus 1, but 3x minus 2 on both sides. So I'll get 13x take away 2 equals, well, 1 times that is going to be x plus 1, 3x minus 2. So, and then, at this point, I'm going to multiply out the bracket, right? Keep that the same there. And on the left, we've got we're going to have 3x squared minus 2x plus 3x, take away 2. Before I move these two things over, let me, the minus 2 and the 3x give me plus x. Now, I'm going to move the 13x over. So I'll get minus 12x. And the minus 2's, because if we add 2 to both sides, becomes, well, nothing. So this is nice. I was worried we'd get a little term on the end, but right, we've got an equation now. To make your life even easier, divide everything by 3. Notice how everything's in the 3 times tables. 0 divided by 3 is nothing. 3x squared divided by 3 is x squared. Take away 12x divided by 3 is take away 4x. Now factorize, right? Factorize. Bring the x out your brackets. Boom. X minus 4. So look at where we are right now. We are, on the home straight now. There are two solutions. Either x is 0 or x is 4. So this is a bit of a mean question because I went in thinking there'd only be one answer, but there's actually two. So 0 and 4. The mark scheme agrees with me, but for future reference, I always like to try, with questions involving fractions, you've got to reject anything that gives a denominator of 0. So if either of these two numbers, when substituted in, would give a denominator of 0, and either of those two fractions, you would have to reject it. But fortunately for us, if you substitute 0, both denominators are not 0. They can be negative, they can be positive, but they can't be 0. So that's fine. And the same thing goes with 4. You're getting a non-zero denominator. That's all you want to avoid. So both are fine. 0 and 4 are the correct answers. So I'm going to move on to 18. Okay, good. So we've got loads of points, and it's a vectors question. We've got to prove that VWXY is okay. Interesting. AB is A. So this whole line is A, and AD is B. Okay. We're told it's a rectangle. Okay, so look, I'm going to say prove. All right, so we've got to prove it's a parallelogram. So VXWY. Okay, right, cool. So prove this shape is a parallelogram. So we know that so we need to prove basically that. So we need to. This is an interesting one. So in order for that shape to be a parallelogram, we need to prove that VW equals YX and YV equals XW. Okay, so let's do that. So because it's a rectangle, we can say that AB is A, DC is also A, BC is B, because one thing we know about rectangles is opposite sides are equal in length, and they go in the same direction because they're parallel. Okay, so let's do this. Let's first work out VW. So if we go VW, the easiest way is to go there, which would be a half VB plus BW. Now VB is half A, because it's halfway. Why did I write 1 over A? I don't know why. Half A plus half B. So that's VW. And YX is YD plus DX, which is a half B plus a half A. And obviously, they are the same thing, right? You can switch around the A's and B's. So we have shown, so VW equals YX. So we've done the first, we met the first objective. The second one, YV is XW. So YV is minus a half. Hang on a minute. I want to communicate. I don't want to leave anything to chance. So YV is YA plus AV. So YV is minus a half B, because we're going against the arrow, so be really, really careful with this one. But AV is plus a half A. And we are now going to do the same thing with XW. So XW would be a half A. I keep skipping the first step. XW is XC. Why am I writing that above each other? Right, I'm having one of those days. XC plus CW. CW. Now XC is a half A. CW is minus a half B. So look, we've and again that's minus a half B plus a half A. So YV is XW. So we've met that condition also. Again, you can factorize, but I think that would not be necessary here. So let's just write a sentence. Since opposite sides have same vectors, they are same direction and length, so must make a parallelogram. Cool. So I'll leave that up there for a few seconds for the people that kind of have scrolled here. But yeah, how many more questions we got? We can't have many more, surely. I think we got 2 more. Okay. Maybe 3, actually. Right, simultaneous equation. Right, non-linear simultaneous equations. Few ways you can do this. I'm going to start by just making y the subject. Y is 4x minus 3, all divided by 2. You know what? We can simplify this as 2x, take away 3 over 2, or 3 halves. It doesn't matter which way, but we've got an expression for y. And what I'll do now is I'm going to substitute this into my first line. So I'll write 4x squared plus 4 lots of, instead of y squared, I'm going to write 2x minus 3 over 2 squared. And that will be equal to 41. Now, what we'll need to do is we need to square that bit there. So let's work out what y squared actually is. It'll be that. You would need a double bracket here. So 2x times 2x is 4x squared. That times that would be, well, the 2's 2 times minus 3 halves. You can think of the 2 and the half cancelling each other out, so it'd be minus 3x. This is the same calculation, so it'd be minus 3x once more. And multiplying the negative 3 halves by one another would be a positive 9 quarters. So the double bracket would be 4x squared minus 6x plus 9 over 4. Okay, that's my y squared component. So let's wrap this up. We've got 4x squared plus 4 lots of this to 4x squared minus 6x plus. And again, all of that's equal to 41. Okay, cool. So we'll expand the bracket out now. I'm going to just change to a new color. Let's make it purple. So 4x squared plus 16x squared minus 24x. Now the 4 and the sort of divided by 4, they cancel out nicely. So plus 9 equals 41. Let's move everything to the left. So what do we got? We got 20x squared minus 24x. And then I want to do 9 take away 41, which would be the same as 41 take away 9, but just negative. So what's that? 32 minus 32 equals 0. Okay. Just going to double check. I don't want to leave anything in the chance here. Yeah, it's 32. Right, cool. All right. Now, I've noticed this. We are going to use AC method, but before that, always check, can we make this equation smaller? Yes. I've noticed 20, 24, and 32 are all multiples of 4. Let's divide everything by 4. With equations, dividing by numbers is fine, but just don't divide by unknowns, because that you might miss answers here. So 20 divided by 4 is 5x squared, minus 24 divided by 4 is 6x, and this is minus 8 is 0. Now we're going to use the AC method. It's a lot easier with these 3 numbers. So AC, meaning 5 lots of negative 8, minus 40. Actually, you know what? Let me do my bit of working on the side here, because I will write underneath later. So AC method means my value of A, that's the number in front of x squared, 5 times the value of C, that's the constant value, is negative 40. B is the middle term, negative 6. We're after 2 numbers that have a sum of negative 6 and a product of negative 40. So 4 and 10, yes. It's got to be 4 and 10 because these 2 numbers are also 6 apart. But just get the right sign. So it'll be plus 4 and negative 10. Because times those 2 numbers, you get minus 40. Add those 2 numbers, you get minus 6. So what to do with these 2 numbers? This is how we're going to split the middle term up. We shall call minus 6x as minus 10x. And that's from this part. But we'll also write a plus 4x after it. Because, yeah, minus 10x plus 4x is negative 6x. Okay, nothing wrong with writing that. Some of you might be thinking, actually, wait a minute, why are you... that's more writing. Why do I want to do that? Well, the trick is anytime you get the AC method right, these pair of factors do something very magical. Okay, so let's factorize in pairs. The first pair, the common factor is not just 5, but 5x. And inside the bracket, you would put x take away 2. The second pair, you would get, the common factor here is 4. So, and it'll be a positive 4 at that. So 4 bracket x minus 2 as well. Now at this point, you should have both brackets identical. If not, you've made a mistake. But mine are the same. That's a good sign usually. So look, the bracket, that'll be the second bracket, x minus 2 from above. But in my first bracket, I'm going to put that and that, right? So 5x plus 4. And again, remember, this all equals 0. So we're almost done now. So you'll notice that we get 2 possible values of x, right? Actually, I'm going to write it on the right-hand side. Either the first bracket, x minus 2 is 0, hence x is 2. But there's also a second solution. What about if this bracket was Hang on, I meant to do this in blue just to signify. So what if that first bracket was 0? Well, you would get 5x plus 4 is 0. So with a bit of magic, 5x equals minus 4. X could also be equal to minus 4 fifths. So we do need to solve for both sides because there are two solutions here. But you know what's going to make our lives a lot easier? This equation we wrote earlier on, right? So there are two values of x. We will need two values of y. But as a reminder, we know y is 2x minus 3 halves. So all we got to do is substitute your value of x into the first one. So two lots, well, x here is minus 4 fifths minus 3 halves. This will be the harder of the two solutions to find. So this will be what, minus... It just occurred to me that I wrote the wrong numerator there. Bear with. Minus 4 fifths. Why did I write that? Minus 8 fifths. Minus 3 halves. Common factor's 10. Yeah, it's a bit of a tough one, this one, guys. So times that one by 5. This one by 2. Okay, so this is minus 31 over 10. Wow. That's a bit of a tricky one. I will check the mark scheme in a minute. So this, I'll write both these in blue just to signify these are my two, these go with each other, right? So when x is minus 4 fifths, y is minus 31 over 10, or minus 3.1 if you will. Alternatively, this one, if I use the same formula, but instead of writing two lots of minus 4 fifths, I wrote two lots of 2. Yeah, this one's a lot easier, isn't it? Minus 3 halves. You get 4 minus 3 halves, which is 2.5, right? Or 2.5. Or 5 halves, if you will. However you want to work it out. Yeah, let's be... this is what 8 halves, isn't it? 4 is the same as 8 halves. Take away 3, 5 halves, right. So just to be nice, remember, with these sort of questions, they have to go in pairs. So either x is minus 4 fifths and y is minus 31 over 10, or if x is 2, y is 5 halves, or if you wrote 2.5, obviously, or this any equivalent decimal works. So I'm checking the mark scheme. It seems to agree with me here, so that's your answer. Well done if you got both of these. We're in sort of grade 7, 8 territory now. So if you got this far, well done. You. Okay, right. Oh, 20's a killer. Okay, we're adding, this is Sir's rationalized denominator now. If you made it this far, you are a champion. I'm going to focus just on this bit first. We'll look at the second bit at the end. So to multiply, to rationalize this denominator, and I'm going to use brackets here. Usually what you do is you take the denominator, the 1 plus root 2, and you just change the plus to a minus. So we're going to multiply by 1 minus root 2 top and bottom. Because if we do it on the bottom, we will get a rational denominator. So let's see what happens for now, just with the denominator. Let's see what we get. 1 plus root 2 times 1 minus root 2. 1 times 1 is 1. 1 times minus root 2, minus root 2. That times that, plus root 2. And root 2 times root 2 is root 4, and root 4 is 2. So it's just minus 2 at the end, because of the minus sign. So these two middle terms cancel out. 1 minus 2 is negative 1. So the denominator here becomes minus 1. We'll come back to that in a minute. The numerator, we'll do this something similar. I'll do this in green, why not? So you've got, what are we doing? We're doing 3 plus 7 root 2, 1 minus root 2. Okay. So 3 times 1, 3. 3 times minus root 2, that's minus 3 root 2. that times that, which is plus 7 root 2. And that times that, this is a tricky one, will be 7, and then root 2 times root 2 is 2. So it'll be, I'm not even going to write the working here, 7 root 2 times minus root 2. It will be negative because there's only one minus here. 7, well, root 2 times root 2 is 4, which is just 2. So it'll be minus 14. Tidying this up, we got 3, take away 14 is minus 11. And the negative 3 root 2 plus 7 root 2 is plus 4 root 2. But remember, because we are dividing the numerator by minus 1, you can do the following. You can say, well, minus 11 divided by minus 1 is positive 11. And that divided by minus 1 becomes a negative 4 root 2. So we've basically just shown that this first bit is 11 minus 4 root 2. Let's do the same now with the second term. What do we get? Well, 4 over root 2. This is the easier one now. We just need to times that by root 2 over root 2. This is an easy one. This would be 4 root 2 over 2, which is literally just 2 root 2. That was the easy one. So look, even if you can do the purple one, you should be doing the blue one, right? So we want to still add 2 root 2 to this. So all that's left to do now is to simplify this. So we remember what we got. We got 11 minus 4 root 2 plus 2 root 2. The minus 4 root 2 plus the 2 root 2 gives me minus 2 lots of root 2. So this should be the answer. Let me check the mark scheme. And yes, it is. It most certainly is. So there we go. 11 minus root 2. 11 minus 2 root 2. Let me just make sure that I've done it in the way the question wants. 11 minus 2 root 2. Bam! Love it. Right, we've got, I think, is this the last one on the paper? Yes, it is. Let's wrap things up. Histogram, frequency, density, and weight. Right, so this one has a bit of everything. Okay, 130. Right, so this histogram is telling us 130 of the apples have a weight between 90 Gs and 165. Now, I'm sort of thinking, scaling wise, that's going to be exactly halfway here, isn't it? So it's like halfway there. So we know that between that, the area of all three sectors is 165. No, not 165, but 130. My bad. That's all three get added up to 130. Now with histograms, we know the area is 130. The areas of the frequency. So we'll call each little box X. So if you want to zoom in, this little height here, I'll call X because I don't know what it is. I don't know what the scaling is. Let's just call it X for now. So for rectangle number 1, the width is 30 and the height is there's 1, 2, 3, 4, 5, 6, 7 and a half X or 7.5X. So rectangle 1 will be 7.5X times by 30, which will be not a whole number by the looks of things. 75 times 3. What's 75 times 3? I should know this. 225. All right. Should know that, but whatever, it doesn't matter. I can get there with a little bit of working. All right, rectangle 2 a little bit easier. So we've got 5, 10, 15, 20x is the height. And we need to multiply that by 30 as well. So that would be, this one's a little bit easier. 600x. And lastly, this last one, it's a tricky one. This is 15, and the height is 10x. So 15x, oh no, sorry. I want to do the height first, don't I? 10x times 15, 150x. Easy money. So remember, the area, we have to add all three of these together. So adding them together gives me 5 on the end, 7 in that one, 975x. And remember, the area we are told equals 130. I'm hesitating because these are not nice numbers, but I don't see any mistake made so far. So, yeah, this is tricky because these are not nice numbers. So the area of all the little squares, just making sure I've not made any mistakes. I don't think I have. Okay. Right, yeah, so let's simplify this. How far can we get by dividing both sides by 5? 975 divided by 5. 1, 45, 9, 3, 197, 26, I think. Yeah. Now, is this... I'm hesitating because these are really diabolical numbers here. In my head, I'm thinking I know that 13 is in the 26 times tables, but is that in the 90? Can I divide this by 13? I don't know. Let's try it. 197 goes into 13 once. Remainder 6. No, this is. Have I gone wrong somewhere? I bet I made a silly mistake somewhere, haven't I? 35, 50. Okay. 90 to 65. I feel like I'm doing something really, really silly. I just haven't picked up on it yet. So, 20. Maybe. Now, this is interesting. And I haven't even got to say, this is, I don't know why this is perplexing me as much as it is. Yeah, stumbled on the last one, eh? So 165. I've definitely drawn these three areas. Have I made any mistakes? Am I just? It just feels like this should not be this difficult. But again, it is the last question on the paper, so maybe it is. Okay. I basically want to know what the scale is. Let's do 130 divided by 5 again. 26. So 975 divided by 5. 1, 9. Ah. 5. 195. X is 26. Now, 195. What number's going to 195? So, 5. I think, I don't know what I did. I think I made a mistake earlier, but I think this we can divide by 13, both sides. So 195 goes in once, remainder 6, and 13 goes into 65, 13, 26, 39, 52, 65, 1, 2, 3, 4, 5, 15 times. So we'll divide both sides by 15, which gives me, sorry, 13, beg your pardon. So if we divide both sides by 13, okay, I've got it now. I didn't make any mistakes, but the numbers are nasty. It's fine. If we divide both sides here by 13, I get 2. And then this side I get 15x. Okay. Now I'm going to do something a little bit. So we could, I mean, at this point you could say one little box is 2/15. Okay. So that would also mean that, annoyingly, this isn't going to be a nice number, is it? But 10x, which would be sort of, this would be 20 over 15, I suppose, which is 4/3. So it means that we're going up in 4/3. This is a nightmare. I've never seen a scaling like this. So this would be 8/3 and so on. So this would be what, 2/3? So each 5 blocks got basically in 2/3. Not nice, but whatever. Okay, this should be enough information now to work out the rest. I hope. Okay. Yeah, no nice numbers whatsoever. There probably are easier ways to have done this, but it is fine. Actually, you know what? Let's work out. So this area here would be 30 lots of 2/3, which is 20. So the first rectangle will be 20. Now, just by eyeballing this area would be twice that, so that would be 40. And let me rub this bit out. Because yeah, I know what the middle bits are, but let's just work out the area of all of these. So the width here is 60, but the height, I want the number that's halfway between 4/3 and 2/3. That would be what, 3/3, which is 1. What number's halfway between 4/3 and 2/3? 1. So 60 times 1 is 60. That's a nice number. Followed by 8/3 times 30. This one here. Oh, man, these are some nasty numbers. If you did it in an easier way, I'm almost certain there is an easier way. Be able to 8/3 times 30. That's just 80, isn't it? But yeah, I'm just working out the area of all these rectangles now. Followed, I'm going to recycle colors. 4/3 times what do we got? The width here is 150 to, this one's going to be a pain, isn't it? So 150 to, what's halfway between 210 and 240? 225, of course. So this rectangle is a bit of an annoying one. So 225, take away 150. What's this? 75, isn't it? So the width there is 75 times 4/3. So 75 divided by 3 is 25 times 4 is 100. Oh my god. And last but not least, the final rectangle. Again, remembering that this bit here on my x-axis is 225. Is that's going to be a width of 45, isn't it? Times 2/3. Well, a third of 45 is 15. 50 times 2 is 30. Okay, so our total frequency, or I will rub some of this working out. So rewind it if you want to see this again. Crikey. They did not hold any punches on this histograms question. It's just the numbers are not nice. That's what makes it difficult. Yeah, the scaling is very tricky. So not impossible, but difficult nonetheless. So the total frequency would be, I'm going to add all these numbers together, right? So what we've got, 20, 40, 60, 80, 100, and 30. Let's add all of those up. Well, all the first digits are zeros. Then we've got 2 plus 4, 6, plus another 6, 12, plus a 20, 23. So it's going to be 330 as your total frequency is 330 altogether. I bet there were easier ways, but whatever, I've gone with this way. So we now know the total frequency. I feel like that's the hard bit over and done with. What else do we know? We know the total. So we know that there's 330 apples in total. The ratio. So there are green or red apples. The ratio of the green apples to the number of red apples. So we'll assume that they're equally distributed, red and green. So cool. The apples are green. Okay, I'm a green. Okay, right. So that, yeah, the next we did the hard bit, really, didn't we? So now it's a matter of the ratio of green apples to red apples is 7:4. So once you know 330, the rest should be a little bit easier going. So that's what that adds up to 11. So 330 divided by 11. Yeah, the numbers are nice now. This is reassuring. 30, meaning the number of green apples times up by 30 will be 210. Green apples multiplied by that by 30, 120 red apples. What are we working out? 20% of the green apples. I mean, this bit's easy, really, isn't it, at the end? So 20% of 210 is 42. If you got this far and you don't know how to work this last bit out, all I've done is 20% of 210 was given to charity. So 42 green apples. How do you like them apples? I'm here all evening. 42 apples given to charity. Is that right? Please be right. I don't want to do this again. I'm hoping on 42. Please, I'm waiting for my laptop to load up mark scheme. Please be right. 42 is via check complete. That was a nasty one. It's, yeah, look, it's because each of these represents 2/3. That's what made it challenging. And I hesitated in the middle. I didn't make any mistakes. It's just the numbers caught me. But yeah, 42 green apples. Tough one, that one. Yeah, hopefully you got most of these all correct. Let me know what you thought in your comments below, and I'll catch you the next one. Mark scheme is incoming. You know what to do. Here's a mock set paper 1, so let's have a little look, shall we? You know all this stuff already, don't you? Okay, so questions 1 to 3. We love to see it. Number 4, 5, and 6. I'm going to stop talking now. yeah, unfortunately at the end of this one, no sort of grades. Yeah, again, mock papers don't really have grades to go with them, but there we go. Hope you enjoy the video. Let me know your thoughts in the comments.